Okay. Okay, good evening, everyone. Today we continue our discussion and some concepts related to predictive analytics, neural network, and clustering. So in the previous class, we had our first 9 experiences. And I think some of you had questions about some of modules that doesn't make sense, that they shouldn't make sense. I also put some extra modules. Last class, I didn't have time to cover all of them, but I just covered the one that you need for a typical machine learning project. So if I have extra time later, I also look over some extra modules that we had. But before getting to the lecture, so let's happy Mid-Autumn Festival. I think some of you might already celebrate it. So you guys, have you eaten the mooncakes? No? So I think it's mostly it should be in the East Asia. So they have like small cakes, mooncakes, and this. I ran out of my mooncakes, but I have some chocolate, so maybe we can just be happy for that. By the way, we are getting to October and November. There is also some big festivals in Massachusetts, especially the Salem area. So they do some scary, whatever things, and like pumpkin carving, and you would enjoy. So you're welcome. You're welcome. So have you ever celebrated Halloween in Massachusetts? That's the biggest festival here. So just especially in the Salem region, that would be fantastic. So maybe you can just go. I think some certain days they have big parties. Maybe, and I think this year they check for vaccine. So most likely, if you already have vaccinated, you can easily join those ceremonies. Okay, so you have 4 comings dues. I mean, homework 4, end of the September, first week of October, your homework 5, and also tomorrow is your first project delivery. And just keep in mind, every month you have a project due date. So for tomorrow, you should have a database, and you just talk about some motivations and the variables that you chose. So pretty much easy. I think the first delivery shouldn't be difficult. And some of you attended the Adobe challenge. So you don't have to submit tomorrow, because the Adobe challenge has different due dates. So in case you attended in that challenge, so you don't have to submit the first deliverable tomorrow.
If someone missed out, can they join somebody's team?
Yes, if you can register, that should be fine. Just, yeah. You know, the due date was yesterday, but I think one of your teams registered today. So just check with them if you can join or not. So it means you cannot join. Just check if you know a team. Just check with them to see if they can add your name in their group or not.
The team member is 2 people to 4 people, right?
Yeah, for Adobe Challenge, you can be up to 4 people.
Up to 4. Professor, after for including the you are
I mean, just check the website.
not given like 3 including the professor.
Okay, so 3 of you. Okay, in last few sessions, we had look over concept of prediction analytics. We checked some general standards, and also we had our first 9 experiences. Then you have assignment 6. So is about, if you check your model, is about Titanic data. So just search for Titanic data set over Kaggle, and based on the workflow that I posted for you, you can basically, one section, you enter the data, you maybe some variables are not numeric, you have to convert to numeric or categorical. Then you do some data prep, divide your data in 2 sections, you train model and do the prediction. So if you attend the previous class, probably this assignment shouldn't take too much time. So again, in that workflow, I had some extra modules that you don't have to have all of them for your project. But in case you have questions, you can, this is your Telegram chat room. So you can join the chat room and ask questions from each other. And you can help each other for this assignment, and it won't be cheating. So it will not be considered as a cheating. So you can help each other through the chat room. But basically, the previous workflow, but instead of that data, you use Titanic data. So you might remember it was about some dealership that wanted to make a decision about either sell or, if either they can sell a car or not. So this time, your target variable is you want to predict if somebody survive or don't survive.
I have a question regarding assignment 4. So we have to submit 3 things. One is a Word document or PPT and the video.
Yes, please. Or maybe you can make a YouTube video and just put the link. That works too. Okay, so these are the textbook readings for this chapter. Please study 4.2, 4.3, 4, and 5. Chapter 4 and section 2, 3, 4, and 5. Especially if you haven't had analytics courses before, you can, by reading those chapter parts, it gives you some good understanding about predictive analytics. Okay, so give me be careful. People don't hire just drag and drop numbers into algorithms and softwares. You need to have insight. You should provide insightful information, or basically, you should be expert in predictive analytics. So otherwise, instead of hiring you, they may hire a high school student and ask them, just drag and drop numbers into some software and just do prediction. So one thing that you need to consider is having bias in your algorithms. Have you guys been here last year? And it was a protest about Black Lives Matters. And they cut some students last year. So it's, generally speaking, so many people believe, I'm not sure if you guys was a part of it, but people believe there is a bias towards people of color. So maybe police is not enough fair for people of color. And actually the movement was much more than that. I'm just trying to summarize it. So it could be something similar in machine learning. So let's say you want to make decision about credit cards. And, one way is hiring so many people to just read all the applications. Another one, using algorithms. So those algorithms help you to make a more informative decisions. Again, the point of using predictive analytics is just make a better decision, more insightful decisions. So let's look at this example. It's about Apple credit cards, and it's about gender bias. So, do you guys know Steve Wozniak? Have you heard about that name? Do you know that guy? Co-founder of Apple. Actually, he was the technical guy who actually created iOS and like Mac products. And let me share. And Steve Jobs, he was mostly like business guy. So anyway,
Visible is wireless, that doesn't play games.
Let me just skip the ads. So what happened? I mean, those credit card decision was not made by people. It was just by algorithms, and they have algorithms to decide how much credit someone should get. And this is a summary of that story. So. What happened? I think I haven't. Yeah, there's the internet here.
Assets, joint income. We don't have joint bank accounts, joint credit cards. We just really don't have anything separate. We don't have any prenuptial agreements or anything like that. It's all the same. The money comes in, it gets deposited by wire in a bank account for both of us. It doesn't even go through my hands or hers. So how could we wind up different? I always think in terms of assets and income, and it's the same for both of us, and that should determine your credit worthiness. But that's not how it turned out.
I mean, my credit limit was 10% of what my husband's was. I just kind of laughed because I was like, it was so low I could barely buy a phone or a plane ticket, and I buy all of his plane tickets. So I was like, we're going to have to use some other card, even though that Apple card's my favorite card to use.
We love the card for a lot of reasons. Very simple to use. We don't have to have 5 different cards for different types of purchases and complicate our lives. But it's really a good card for its benefits. It was just sort of a surprise. Why would we get different credit limits? Maybe some accident happened.
Basically, I had called into Goldman Sachs like a couple times, and they told me that they could reevaluate it in 6 months. But when I called, they contacted me after this stuff aired, and I talked to a gentleman today who said that they are reanalyzing my credit score. So I have a feeling it'll be based off of both of our numbers rather than some number from I don't know how many years ago, maybe before we were married.
So I don't really get totally upset about it. Like I said, I didn't come out when Janet got her low credit limit months ago. I didn't try to espouse anything, It was just a post by somebody else, by Mr. Hansen. And I said, we've got a similar situation. I was adding it sort of as a little humorous, little point adding on, but it was sort of an amplification.
Yeah, so one of the things you need to consider your models. You shouldn't have bias. At least you try to minimize the bias. It might have different reasons. So basically, the algorithm doesn't know anything about gender, but I mean, I just could guess maybe, when they wanted to train an algorithm, the number of female observation might be much less than male. So when they train a model, the model was trained very well for the male observations, but didn't have enough observation to be train on female cases, or maybe other reasons. But so you need to consider these things. One of the countermeasures that you can do resampling algorithms. So you make some artificial samples for the case that you have low observation. Please mute your speakers. Who's not muted? I think Giawei, you should mute, so let me just mute you. Okay. So again, here one possible reason could be they have less number of female in their historical database. They can, one of the countermeasures is resampling. Basically, you make some artificial observations, in this case for female applicants. So when you want to train your model, you have enough observation in both classes. So hopefully you have less bias. So keep in mind if you try to, I'm not sure it could be related to your project or not, but maybe you can check for bias in your algorithms and you try to reduce that things, and it could be a bonus for your project. So let's say, have you heard of sensitivity and specificity? Okay, so basically you look at the accuracy of your model in different groups, and let's say sensitivity tells you how to, let's say if you have two classification problem, and let's say sensitivity shows you how you are good in predicting the upper class, specificity shows you how you are good in predicting the lower class. Let's say if you are upper and lower class, or death and survival. So for credit card, maybe you can look at the error of your prediction for female and males, and you can show, that difference is how much is the differences of accuracy in different groups. The purpose of this class is not teaching you some statistics, but in case if you need for your project, you can Google how to find bias and how to improve the situation. One way, just doing resampling. So there is some resampling modules that you can drag and drop. So it just makes some artificial samples in the group that you have low number of observations, and so it helps your model to make a better model, less biased model. Okay, this week we checked some issues that you might face in modeling. One, I just talked about bias, then outliers, missing values, maybe some cases you need to transformation. Also, next class I talk about cross-validation. So I think it was Chaitra's, I'm not sure if I pronounce her name well, but I think Chaitra, is she Chaitra? Chaitra, I think her question was how we can rely on a certain model. So cross-validation is one of the approaches that lets you just test how reliable is your model. So instead of having train one test, you might have train five tests. And then it gives you more evidence for checking reliability of your model or not. So in the next class, when we do hands-on experiences, we can check those things through 9. So outliers. So I think the meaning is very intuitive. It just means you have one observation, it's just far from the rest of your observation, or you have few observations that are way more different than others. Sometimes it could be a typo or some reasons. Sometimes when you have one observation very different from the other observations, sometimes maybe your sample is kind of very odd, and maybe for some class of your observation, you don't have that enough observations, so it just looks as an outlier. For example, let's look at this example. I read the example. A new coach has been working with a long jump team this month, and the athlete's performance has changed. Augustus can jump 0.50 meter further. June and Carol can jump 0.6 meter further. Here are the results. So Augustus, Tom, almost everybody has some improvement except for Sam. So actually, you shouldn't just exclude that observation, but look at the mean. The mean of the team progress is almost zero, actually a little less than zero. I'm not sure, maybe he was drunk or he was just upset, so he couldn't jump well. I mean, it might be a reason. Actually, it's a good question. In such a case, you should go for the reason. What was the reason? Maybe it was just a typo. So somebody had a typo. But again, it just shows that one outlier can change the reality. So you cannot show the reality well. And again, it's one of the things that you as a business, somebody who's expert in business analytics, or at least some people who wants to use analytics, you should be considered. So you shouldn't just drag and drop your numbers into a software. Before doing that, you should check so many things. One of them is having outliers. So these could be outcome of having outliers. Your range, median might be changed. Median usually won't change too much, maybe a little bit, but range, mean would affect significantly. One thing, it also can affect your prediction. For example, here you see a simple linear regression. You can use it for predicting. As you see, even one outlier could change the slope significantly. If the outlier is along with your prediction line, it may not change that much, but if it's far from the regression line of the others, it might affect the slope of your regression line heavily. So the best reaction is just seeing why you have outlier. I mean, first try to see if you have outlier or not, then ask the question, why you have such an outlier. There is some statistical test for depicting outliers. One of them is Cook's D-test. I'm not sure if you have in your previous courses, but again, just search. I mean, you don't have to use Cook D-test in your project. Maybe just visual observations enough to finding outliers. But some outliers, sometimes you don't exclude the outliers. You try to find the outliers. One case could be fraud detection. So I'm not sure is it the same for every country, but you as an international student, I think if you transfer too much money in or out of US, it would be an outlier, and I mean, your bank would call you and ask you what happened. So basically, they don't have too many people to check all of the transactions. They just have some algorithms that try to find outlier, basically money transformation. In medicine, so some strange or, weird health situation may just drag attention of your primary care or in public health. So again, depends on the application. Sometimes having outlier could have some meaning. Maybe you are a drug dealer who wants to transfer money. So they would ask why you have such an apply transaction. Again, some cases could be just a typo. Here you see like big, somebody just pressed G twice, or probably 55 here is just a typo. So if it's just a typo, maybe we can easily fix it. But again, don't just exclude the observation. It could be either a sign for something, or it could be a typo that you can fix it. Box and Whisker Plus is also a good tool to find outliers, and basically you draw your first, second, and third quartiles, and this plot also can easily show you what's the outliers. For example, you can have lower outliers or upper outliers. There's a statistical formula. Please search for that. So you can manually calculate the threshold for upper outlier and lower outliers, and everything above and below that would be considered as an outlier. Any questions so far? So I wait 1 minute for your friends over Zoom, because most of you are over Zoom. So in case if there's a question, let's see. No questions. Okay, just I wait 1 more minute. Okay, by the way, recently I've noticed some of your emails goes to my junk folder. So if I don't respond your email in 24 hours, either send me another email or text me over Telegram. So it was weird. Recently I've noticed some other university emails went to my junk folder for some reason. I don't know. But anyway, if you see I try to respond quickly. So if you think that I don't respond quickly, just send it a text over Telegram is usually better, because in Telegram I don't miss your messages. Okay, let's talk about missing data. So based on these two figures, do you see any differences in the type of missing data? Yes, right. So on the left one, maybe one of the responders, was not willing to provide any information. But in the right one, maybe you have some missing based on the type of variable. I've noticed actually, it was really interesting experience that I had recently. I was Zooming with one of the students. She's not in this class, so you don't know what is her name. But I think we talk about some age restriction for registering some places. And I've noticed she really I made her upset. So some people maybe talking about some information is not pleasant, so they don't provide information for you. So, these are some reasons for having some missing. If a unit non-response, could be somebody's not at home, maybe they don't pick the phone or dies before study. That's weird. So item non-response, maybe refuse to respond. I said, I think in many cultures, some males or females don't want to respond to certain questions, or some measurement issue. Okay, so missingness could be completely at random. So there is no certain reason, it just happened. Some type of missing are missing at random. For example, people who work in the service section or service occupations, maybe they are not happy to provide about income information. So the last group is missing not at random or systematic missing. Basically, there is some dependency between missingness. For example, a respondent with high income, less likely to report income. So when you do modeling, we try to avoid missingness at not random or systematic missing. So we avoid it. The best case is completely at random, but missing at random is okay. So if you see some dependency between randomness and some certain variables, you should exclude from your modeling. Don't bring it for your modeling. But if it's missing completely at random, or at random at least, there is some algorithms that you can use for imputing those missing values. So, let's see. So in these cases, I mean, if it's at random or completely at random, you can either delete those observations, but deleting the observations sometimes is not really good, especially if you, for some certain group, you have less number of observations. Let's say you're talking, I mean, you're getting information of people for credit card. And I just said, I mean, based on my own experience, maybe it's not true for everyone. Let's say if female applicant didn't provide their age information. And if, let's say you have some missing value, now you want to drop those observations. So it just means now you don't have enough observation for female group, maybe you end up having a bias. So again, we usually try to do some kind of imputation, especially if you don't have too much missing values. Also, usually also we don't drop the columns or variables unless maybe more than 90% of a certain column is empty. There is some certain types of imputations. Again, imputation means you fill out some missing values. Some of them statistical imputation. For example, you find the median of a column and you impute for all missing or sometimes mean. There's also some predictive way of imputation. So you use some predictive method to predict the missing values. So simple imputation methods are much faster. And there is no guarantee if you use some predictive method for imputation and you get better results. So we may just use some simple statistical imputation models, unless the missing data is too much important. So you may try some predictive algorithms or some algorithms such as maximum likelihood or multiple imputation. So some cases like here, look, so it's about people's grades. And if you just see, in this case, May's respondent didn't want to provide the grades that much. So if you drop May's observation, maybe your model won't train very well for males or and for female students, maybe you have better prediction. So here, if you just drop those missing values, you end up not having good model for male applicants. Maybe for female applicants, you have much better model. So in some cases, I mean, you could have pairwise deletion. So you just focus on certain variables. For example, here, 95% of students talk about their nationality, 75% about family income. So you can end up having two different distributions for income and nationalities, but you cannot just get a big overview, because each time you just focus on some portion of your data that you have more observation. Here you just see a case of imputation with mean. So 70 out of 500, you didn't have the information of their income, so we imputed with mean. So when you impute with mean, around mean, you have a higher bar chart, because now too many of them imputed with mean. So frequency near mean is increased significantly. So before imputation, it was 80, but after is like more than 120. So the reason, so imputed with mean, so you increase observation significantly. Imputation. One way of imputation is just, just for the cases that probably you have less number of observations and you want to be less biased. So maybe you try different imputation models like mean, median, predictive, and then you get average of all of them. Okay, so for statistical machine learning algorithms, you need to consider some prerequisite of statistical modeling. One is having a normal distribution. So usually if your data doesn't follow normal distribution, it's not a good idea to just apply a statistical algorithm. For example, let's say if your data is heavily skewed to the left or negative skewed or positive skewed. So is something that we usually try to avoid. If your data is skewed heavily, usually instead of using the raw data, we do natural logarithm of your data. And just usually when you do natural logarithm, your distribution would change to something more of a normal distribution. Or kurtosis, if you have high amount of kurtosis, maybe again, it's not a good idea to use statistical algorithms. So I think now you got some feelings why data preparation and data consolidation might take 80% of your time, because let's say you have 20 variables, you check if you have bias, you check how's the quality of your data, if you need imputation or not. Even something more, maybe you can check for outliers. Having said that, it just takes a lot of time. The reason the last part, which is modeling, usually takes less than 20% of your time. Even you remember in the previous class, I used a already cleaned data set. So when I wanted to train a model over 9, it didn't take more than 30 minutes. Even it was your first time watching that, because the data was already clean and prepared. So using 9 didn't take too much. But in reality, before just using any algorithm, you need to do a lot of things for data preparation. Let me talk about bias, precision. Okay, let's talk about some algorithms that you might need for your project. One of the most well-known is neural network. I skimmed through some neural network concepts. I think for some it's boring, but exactly today morning, I skimmed through deep learning, which is a version of neural network. But again, for this course, I have to review. So just keep in mind, it doesn't matter which type of algorithm you use. You might use neural network, SVM, decision tree, linear regression. It might look scary and very complicated, but for your day-to-day work or like this class project, you don't have to know too much details of those algorithms. It probably, and most likely for, let's say, your final project, if you need to neural network, you just drag and drop a neural network module and just take care of the input and outputs, and that's it. So if it's, again, linear regression, still you just use its association module. So having said that, I don't go too much in details, but I just skim through some concepts that might help you to understand further about these algorithms. Neural network is basically inspired by human or biological neural network. So you have some synapse and dendrites. So they get some electrical pulse from the nearby neural cells, and they change those electrical pulses based on the type of cell, and they transfer to axon, and they transfer to next neural cell. So similarly, when you use neural network, instead of synapses and dendrites, you have some input variables. So you multiply those input variables to some certain coefficients and transfer to the hidden layer, which could be axon here. You multiply to some certain number and transfer to the last layer. In the last layer, based on the outcome of, let's say, axon or soma cells, you end up deciding, is it belong to this group or other group, or maybe you can do some regression. So I just talked about statistical models, and I said if you want to use a statistical algorithm such as linear regression, you need to consider prerequisite of statistical models, one of them having normal distribution. The good thing about neural network or other so-called black box algorithm, which is one of your assignments, you don't necessarily need to consider a statistical prerequisite. You can just put any kind of data with no normal distribution without considering linear relationship. And based on the coefficients that neural network finds for you, you can do your prediction. So it brings a lot of flexibility in terms of being able to handle so many types of algorithms, so many types of problems. So now let's look at this artificial neural network. So instead of synapses and dendrites, we have some inputs. Like could be x1, x2, and you multiply to some weights. You sum those weights and transfer to the next layer. Again, you do some similar multiplication of the weights. And finally, in the output layer, based on the value that you gain, the value comes from different matrix multiplication, you end up deciding your final target value. So let's see. These are general concept regarding artificial neural network architectures, like feed-forward, recurrent, associated memory, probably. So feed-forward is the most common way of finding those weights. This is the most popular architecture. In neural network, you can do both supervised and unsupervised learning. So again, supervised learning means you have a target variable that you try to predict. Unsupervised, you use it for categorizing your data in different subgroups. One of the applications of neural network is for image processing. So if you want to do image processing in your project, so you need to do two things. Image, text, or non-tabular data should be converted to tabular data. For example, the image consists of some pixels. So each pixel could be identified by its color. And you need to just use some other modules to convert a textual document or a image document. And those modules need to convert them to the numerical equivalent. After converting to numerical equivalent, you can just feed them into a neural network. Neural network just multiply those numerical equivalent to some certain weights, and at the output layer, based on the value that you gain, it would decide it belongs to which category. I think today morning in my other class, I talked about image classification, and the outcome could be a human, dog, or car. And based on the outcome of output layer, your model would decide your image belongs to which group of observations. Any questions so far? I know today might be a little boring because I just have to review some concepts, but hopefully from next class that so hopefully from next class that we get back to hands-on experiences. These things makes a lot more sense. In one of your hands-on experiences, we do text mining. So we use some text and use some neural network to decide if a text has a positive meaning or negative meaning. So the target variable is either positive or negative. You have some text, you use some module to convert those texts to numerical equivalent, then the remaining you just have like a predictive module that decide if your text would have a positive or a negative meaning. So one of your friends asked about best method to identify missing values. I mean, basically NIME is easy. Just drag a missing value module and it decide and would ask you which type of imputation you want. For example, you can say you want to impute based on median, mean, or other methods. So anyone, I'm not sure if you had time to do your assignment. So ANN, or artificial neural network, is a black box model. What could be the problems of or benefits of black box models? I think for benefits, I just talk about how relaxed is this type of models. So, for example, you don't have to check the statistical prerequisites. You don't have to have a normal distribution. You can just use any types of data you want. So, but there is some drawbacks. So basically, these weights you cannot prove why you have such a weights or how the model are not that much transparent. So the way that they find those weights of, because each link here, it just means your input multiplied to a number and transferred to the next layer. So these are searched randomly and also through some optimization methods. So usually black box models are not that much transparent, and the good thing, usually have a high accuracy. So there is some, trade-off of being a transparent or high accurate models. Okay, so let's talk about sensitivity analysis. This is actually an important concept. I put the formula here. Is basically you check the variance of your actual data, variance of the expected value, and you divide variance of expected value divided by variance of the actual value. But the only important thing is you check how important is the variable for predicting a certain outcome. Let's say COVID. So your dependent variable is somebody dies or not to die. And your input variable could be some medications, patient age, weight, BMI, heart rate, maybe blood pressure. So these are input variables. This formula helps you to identify which variable is much more important. For example, let's say your mother would say the importance of blood pressure, age, let's say, or remdesivir. So remdesivir as a medicine is highly important. So the medical doctors, they can focus on these three variables. For example, if they see a very old patient, maybe they give them higher priority. Or if they see somebody has high blood pressure, they maybe prescribe some medicine to reduce their blood pressure. Or if they see remdesivir is a very important variable, which is actually a medication for risk of the death, maybe they focus on that and they just prescribe that medication more. So for healthcare domain, usually variable importance is really a big thing. So you don't want to just predict somebody dies or live. For you finding the variables that attribute in their survival is also a lot important. So we check the variable importance in those cases a lot. And for your final project, this is the important thing. I expect you guys talk about the importance of variables in your prediction, even if your project is not about healthcare. So there is some modules that help you to understand the importance of variables. And especially if your project is about healthcare, is actually really important thing to mention. I'm pretty sure for you guys who in Adobe Challenge, this is a very important thing to do. I haven't looked at the data set, and I think I'm totally blind about that. But let's say if your data is some certain categories, maybe it's a very good thing if you investigate if you are biased in your data set or not. Especially, these days, some social movement like Black Lives Matter is very significant. So people want, not only for police forces, they also want their models would be less biased. They don't want to have biased models. So also this is really important thing. So I think in terms of competition, checking the variable importance and avoiding bias in your models is really a big thing. Let's see the data set, then decide about that. But no matter which kind of data set you have, variable importance is a big thing. So just consider it for your either final project or the Adobe Challenge. So there's some certain disadvantages for ANN. One of them I talk about black box model that is very hard to find internal relationship. So if you use decision tree, you can just talk about the rules, but for artificial neural network, it's almost, there is some research to find some, to basically decipher or explain the interrelationship of neural network, but it's not that much common. Also, when you have too much observation, usually training a neural network takes a lot of time. I think last class I talked about differences of supervised and unsupervised learning. Okay, so I think if you are in the marketing major, customer segmentation could be a big thing for you, because based on the customers' characteristics, maybe you need to consider different basically marketing campaign. So maybe the demographics is psychographic, and also basically the way that they use some certain products could be very important. One of the things, so maybe it could be YouTube ads. So, I mean, they have, based on the type of people who watch YouTube, they have different types of ads. So I think, especially if you're in the marketing major, I think customer segmentation could be a good project for you. So you try to use some machine learning algorithms to basically categorize your customers in different groups. So that could be a really good thing. And it just helps you to have direct marketing, and basically you boost your basically sales. If let's talk about sales marketing. So most likely, if you have a better ad and to have a make a better decision in terms of marketing, hopefully you improve your company's income. These are major application of clustering: identify natural groups of customers, identify rules for assigning new case to classes for targeting diagnostic purposes, provide characterization, definition, labeling of population, decrease size and complexity of problems for other data mining methods, and could be sometimes good for finding outliers. Also for clustering, usually, I mean, you should refer to your background knowledge, because in clustering, you're not, there is no biblical rule for knowing, I mean, how many subgroups you have, or how you should categorize your customers. There is some certain methods. So they call it inter-cluster distance. So let's say if you check the intercluster distance, maybe for 3, 4, 5, 6, and also at the same time, you don't want to have too much of clusters. Let's say maybe you have 20 clusters, your intercluster distance could be less, but usually we avoid to having too much of clusters. I don't want to go to the detail of clustering, but let's say based on your background knowledge, you want to categorize your observation in 5 groups. You just find 5 random centroids, and you assign all of the observation to closest centroids. And after having, let's say here we have 5 types of observations, then we find the actual centroids of each subsection and then reassign. So in K-means, we do assigning and reassigning and finding the centroids in multiple times until your intercluster distance doesn't change significantly. Again, no worries. I mean, for many of you, maybe it's not that much relevant, but I just want to skim through those concepts. Okay, I think let's say that we dedicate next class for outlier detection and also cross-validation, because I think it could be very important for your final project, and also if you are in the Adobe challenge. So having said that, for Adobe challenges, after understanding your data, please reach me. I can provide some insights for you. For example, today I talk about the variable importance, that it could be a big thing for your project, and also maybe avoiding bias. On top of that, you should be able to present your outcome in a very good way. So for example, if you do sensitive analysis, finding the importance of variable, but you cannot talk about that, people don't buy it. So you should provide good explanations of your outcomes. Anyway, so when is the Adobe Challenge meeting? So I think tomorrow, it was this time? 8 Eastern time?
8 Eastern time, 8 to 10.
Okay. Okay, so let's watch it. And after watching the, watching the meeting or the video, maybe let's reach me later and I can provide some insights. And so hopefully all of you win. It would be great if we have so many winners from Clark. Especially, I will be glad if you get some internship or full-time jobs from those cool companies. That would be awesome. But again, let's say if you end up getting any of those rewards, you get A and you would be happy for the rest of the semester. But that needs a lot of effort. So you need to do a lot of tuning, and during the competition, you can, but you don't have to submit your assignments. I give you extension up to the end of the competition. Even if you're not fortunate to win the competition, at least you can use all of your efforts for your final project. So, and you already have extension for your assignment, so you can hopefully. I would be more than happy if you win, but it's a really good experience. Okay. Any question about today's boring lectures, I guess? So yeah, when we go to actual hands-on experiences, these things make sense. So what I mean from variable importance, what I mean from bias or outliers. So you actually do, and you find them. So hopefully these things makes a lot of sense. But I have to, skim through these concepts. So hopefully next class would be much more interesting. So no question? I don't think your friends over Zoom has a question. So that's for today. Thank you very much and see you next week. If you are in the Adobe Challenge, probably see you sooner. Cool. Sure.
For the project, so for the dragon here, but I just hear in the council, you give them another few days time after the competitions.
Are you in the competition or not?
No.
No, you are not.
Yes. So it should be tomorrow.
Okay, are you in the competition? So you're a part of the team in the competition, right?
No, I'm not a part of the team.
So you should submit the deliverable.
Project deliverable
tomorrow. Yeah, you should submit by tomorrow night.
Okay. So for the project group, you said in the class is up to 4, right? Two people to 4 people.
For the challenge, not for this. I think it's max is 2.
Oh, max is 2.
For this project, max is 2. If you're in Adobe, max is 3, but including me is 4.
Or even for the competition is 4.
Yes.
Okay. And for this and for the assignment 4, this is a group work, right? It has, or it's for individual.
This is individual.
Individual.
Yes.
Okay.
Hello.
I just wanted to ask if this is the dynamic data set that you're talking about.
Yes, I think it has to train and set. I used train one.
Because I saw Only this one CSV.
Bob? Go to... Oh, that's a weird one.
Okay.
So search for another one. Sorry.
There's another candidate.
Oh, okay.
Maybe there's another.
So I saw your names and picture in the first assignment. So I don't want to mispronounce it. So say Sino. Sino.
Yes.
Shati. Sino Shati.
Jinya.
Jinya.
Yes.
Jinya.
Aditi.
Aditi. Okay. Awesome.
Is it this one? Train and test.
I don't like it, but that's fine.
Okay. Because then this will have the train and test data combined.
Yeah.
And then we'll have to like segregate it like 80-20 or something like
yes.
that. Okay.
But there is another one that is already separated in train and test, so that's easier.
So, okay, let me look for that.
But that's fine too.
Okay, thank you.
You're
Professor, I had a question.
Sure.
I'm actually working in an array for
Yeah. Did you find the one that has
this project
training and
for
test?
cryptocurrency. Oh, I just the first time that I looked at the project, which is first company. So you want to use this? We were actually looking at an approach. So Dr. Eisner told me you're quite useful. One thing we were looking to find out was, Coinbase as a platform and most of the other centralized platforms, they don't have too many exciting points. So we want to check, what are the different types of coins out there, and what is the way to find out which platforms actually have those? I want to probably.
Yeah, sure.
And if you understood my question.
Yeah, I exactly understood your question. So there's some ways. It's a long discussion. So could you find? Is it okay? Do you guys have a due date for this?
Not really, but like we have this thing to submit by next week. So for a conference, we need to submit the final case study. So actually, it's by next week.
When next?
Probably the 30th.
Okay, could you find me? If you cannot, oh, cool. Let's take everything in the So try to find it tomorrow afternoon. If tomorrow afternoon you couldn't, or I would be in a meeting, find me on Friday.
All right, yeah.
Friday, maybe after, or we can do it. I mean, okay, anyway. So either find me in person or Zoom, that's fine.
What's the time?
Tomorrow, usually, most likely afternoon, I'm free. Friday, maybe after 4, I'm free.
I'm sorry.
My office is 333 here.
Okay.
But you can find me over Zoom.
Right.
So it's the same classroom.
Got you.
And also, you can text me over Telegram.
I'll do that.
Okay, cool.
Thank you so much.
You're welcome.
Hi, Professor. I just had a really quick question for the outline dude.